Precision and accuracy usually get used interchangeably in everyday conversation, but in science they mean two completely different things. And we'll discuss that more in this section. The uncertainty that we talked about in the measurements that we make come from a couple different sources. So it can come from limitations in the instrument that we use. It can come from the person that's doing the measurement. It can also be a flaw in the experimental design. And there is always uncertainty due to nature's random behavior. So we're going to discuss how we can understand how reliable our measurements are, and we need to understand those limitations in the measurement. So in the lab, no matter how hard you try, there is always error in your measurement. Now, accuracy describes how close multiple measurements come to the actual value or the actual quantity that you're trying to measure. And so accuracy is similar to if you think about a bullseye. If you had accuracy in shooting, you would be close to the bullseye. Precision, on the other hand, tells us how close the repeated measurements are to each other, or how reproducible that measurement is. So it's the clustering of the shots on our bullseye. Now we can have the case where we have an accurate and precise measurement, like the bullseye on the right. So they're clustered together closely and at the bullseye. We can have precise measurements that are not accurate, so cluster together, but they're not near the bullseye. So how would you, if you were shooting, how would you adjust if you saw the shots clustered but not at the bullseye? Well, you might have to adjust your scope or adjust your aim in some way to bring those shots down closer to the bullseye. So there is something external that you can do in order to correct for that case. We also can be not accurate and not precise. So for our bullseye, the shots would be all over, like the far left side bullseye in our picture. So imprecision is caused by random errors. So no matter what experiment you do, there is always random error. These tend to be much smaller sources of error. They result from the random fluctuations or chaos in the universe. And so we can't correct for random error, but what we can do is we can make multiple measurements in order to average out the random error, because random error happens both above and below the value that we would expect. Accuracy is caused by systematic errors. So systematic errors tend to be much larger sources of error. They tend to be caused by the experimenter or the instrument or the way that the experiment is designed. So we can correct for these systematic errors. And this is why we tend to run controls, so that we can see how far we are from the actual value. They do not average out because they are consistently too low or too high of a measurement. But again, we can try to correct or improve our experiment to reduce our systematic errors. Let's look at an example. So we have students, they're measuring the mass of an object. That object has a known mass of 10 grams. And if we look at their results, we can see that student A made 4 measurements. How would you classify those measurements? Well, they're kind of scattered all over, so we would say that these are not precise because they're scattered. They are also not accurate because the averaged value is higher than our true value. They're not precise and not very accurate. Now, student B, all of their measurements are pretty closely grouped to each other, so these are precise because they're grouped, but they're not very accurate because we're not close to 10 grams. So there's maybe some room for improvement in this student's technique or the way they design the experiment. Now, if we look at student C, they're grouped closely together and they're very close to the true value. So this would be precise and accurate. Let's think about the errors that are happening here. So every experiment has random errors. So all of the students, A, B, and C, are experiencing random error in their measurements. However, student C, random error would be the largest contributing factor. If we look at student B, the largest contributing factor is systematic error because they all fall below the true value. So sometimes if we look at it in a graph, it can become even more apparent.